All right, lesson 1.7, negative exponents and reciprocals. All right, so here, you know what? I'm going to give you guys an example here. Grade 9 math. Grade 9 math, if we would have had something like, let's say, 3 to the power of 6 divided by 3 to the power of 3. Actually, no, I'll do a different one. 2. Do you guys remember what the rule was for dividing when you had the same base? Yeah, you subtracted, right? That'd be the same thing as 3 to the power of 6 minus 2, 3 to the power of 4, right? Okay, so what we're doing now is this. We're going to say, what if it was like 3 to the power of 2 over 3 to the power of 6? Now what's going on? So what do you guys think? That using our same logic there, yeah, that would be, and it still holds true. That would still be 3 to the power of negative 4. Now, this lesson is about what does that negative 4 even mean, right? This is like these negative exponents. Okay, so in grade 10, it's not as bad as you think. Maybe you can tell from looking at this. What about this? If I look back at this one, remember how this worked? 3 squared, that could be written as 3 times 3. And 3 to the power of 6 would be 3 times 3 times 3 times 3 times 3 times 3, right? 6 of them. Well, look what happens here. Those 3's would cancel with those 3's. And on the bottom, we've got 4 3's left. That could all be written as 1 over 3 to the 4. If you guys were to make a prediction, right? Because there would still be a 1 up top, right? There'd still be a 1 up top, and that one's a 1 over 3 to the 4. So kind of what this is saying, right, is that 3 to the power of negative 4 really is the same thing as 1 over 3 to the 4. They are the same thing, right? So what if you guys are kind of like looking into the future here, what I'm going to teach, what do you think negative exponents are going to do? Well, yeah, they would make it a decimal like that. But yeah, it's really going to flip it down to the bottom, right? This was 3 to the negative 4 over 1. Now it's 1 over 3 to the 4. It flips it upside down. Negative.
Talk about this, that there's a dimension with the fractions. You talked about this last year, pretty sure.
Yeah, maybe.
Because whenever you flip it, it just switches exponents.
Oh, yeah. Yeah, probably then, yeah. Yeah, so that's what negative exponents are going to do in the end here. So this is another way of kind of saying the same thing, right? So if you've got 2 times 2 times 2 times 2, well, that's 2 to the power of 4. And then 2 times 2 times 2, power of 3, power of 2, 1. And then 2 to the power of 0. Do you guys remember anything to the power of 0? That's one to remember here, too. 2 to the power of 0 is 1. All right, so what is like 4 divided by 3 times 56 minus 7 all to the power of 0? 1, right? So anything to the power of 0 is 1. Okay, so let's look at the pattern as we keep going down though, right? So if I've got now 1 over 2, well, that's going to be 2 to the power of negative 1. See how this went? Like 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, and negative 4. So you can just, like, see that power. It's 1 over. And that's called the reciprocal, right? That's why the name of this one was negative exponents / reciprocals, because negative exponents are the reciprocal. It's flipping it upside down. Yeah, okay. Yep. Okay, so let's look at some of these now. So here's our general rule first, right? This is all written all mathy, right? Where it's saying x to the power of negative n is the same thing as 1 over x to the power of n, right? That's really what we were doing there. You could throw numbers in for that to make more sense. X you could replace with 2, n replace with like 3 or something is equal to 1 over 2 to the 3. That's exactly what I was just showing you like above, right? So they just have x's and n's to kind of give it like a general rule for math. And then this other half of this is saying if I had 1 over, let's say 2 to the power of negative 3, well, that would be equal to 2 to the power of 3. So what that part's saying is if it started out as like 1 over 2 to the power of a negative number, what that does is it flips it back to the top. It's doing the same thing. So then that would flip around. These two would flip. So we get 2 to the power of 3 over 1, which is just 2 to the power of 3.
You
No, you don't. You never have to write over 1.
Okay.
Yeah.
Like, will it be marked as wrong if you?
It would mark either one right on that thing. Yeah. Okay, so let's do some examples here. So, yeah, let's skip these and do some examples. So, okay, evaluate each power. And evaluate here really just means like get it like as simple as possible, like just down to like a fraction. We won't do a decimal. But, all right, so 7 to the power of -2. What would that be? How could I rewrite that? That would be the same thing as
7 to the power of 2 over 1. No.
1/7.
to the power of 2. Perfect. Yeah, so see how we just got rid of the negative when we flipped it, though? So it's 1/7 to the power of 2. Okay, so that'd be the same thing as 1/49. There. And that's good. We'll just leave it as a fraction like that, right? That is the answer. Okay, 1/4 to the power of -2.
That's just 4 to the power of 2.
4 to the power of 2, right? Just got flipped right back up again. 4 to the power of 2 is 16. All right, -6/5 to the power of -3.
5 over 6 to the power of 3.
Yeah, good. Yeah. Yeah, so the way I would do this, I just forget about the 3 for a second. As soon as I see that exponent's negative, I'm going to switch them, right? We're going to just like swap these two upside down, right? So let's just swap those two right at the bat. So that'd be the same thing as 5 over -6 to the power of 3. Yep. Now, I might answer this too, so just let me carry on a little bit. So I put this -6 down to the bottom, right? Do you guys remember from last year, though, that I harped on this a lot, that 5 over -6 would be the same thing as -5/6, which would be the same thing as -5/6. Like, those are all really giving you the same thing. They're written this, like, it doesn't matter where that negative goes. I put it to the bottom just to flip the whole thing, but it didn't matter at all, right? So, okay, I'm going to change that a little bit. I'll put that negative just out front, maybe, over 6. Okay, and then that's to the power of 3. So, -5 to the power of 3. Anybody know what that one is? Yeah, and it'll be negative. I'll make it -125 over, and then 6 to the power of 3. Yep.
Let's just actually finish this part.
Yeah, we'll finish this one. Yeah, so 6 to the power of 3. That's right. Okay, yeah, 216. So 216. There you go. The most simplified would be that one.
You'd give more.
You'd actually simplify it that way. Yeah. Like all the way. Actually give it, like, cube them both, right? You cube that one and you cube the bottom.
Yeah.
Okay. It is handy when you see these exponents, right? Like 6 to the power of -2/3. To just break it down into parts, right? The negative means that it's reciprocal, so you're flipping it upside down. The top number would be your power, and the bottom number would be your root, right? If you were changing it back into a radical. All right. Let's look at some tougher ones. Okay, evaluate each power. Okay, so we're looking at this one. How can we rewrite that? That would be the same thing as, so that's a negative on there. So how should I rewrite that 16 right off the bat?
Put it in.
Well, we won't do that. Let's rewrite it though as the reciprocal. It won't be -16.
Oh, no, sorry.
The negative on the exponent doesn't do anything for making the actual number negative. The negative exponent flips it upside down. You're probably ahead of us. I'm just going to flip this one upside down, this 16, as 1/16. Right, that's what the negative did there. And then that is still to the power of 5/4. No, because I flipped it. Right, I took care of that. Once I flipped it, then I no longer have the negative, right? Because that's what that negative did. The negative flipped it upside down. Okay? So that's flipped upside down. So now this is like one of our questions from a book. So typically what's going to be the easiest here is to do the the root first, because then we're going to make our numbers smaller and then bigger. It would be harder if I went to the power of 5 and then 4th root of that. So let's go 4th root of 16 is 2, right? So what I can do is I can go, okay, and 4th root of 1 is still 1. So that would be the same thing as 1 over 2. And I've still got to the power of 5 left. I haven't done that part. Okay. And then to the power of 5, we need to just go both those numbers to the power of 5. So 1 to the power of 5 is 1 still. And 2 to the power of 5. Yeah. Someone said it. 32, yeah. Which makes sense, right? 16 to the power, or sorry, 2 to the power of 4 was 16. So times 2 again would be that 32, right? Okay. All right, let's do this one. So what does that negative do? What are we going to do first? We're going to, yeah, old flipperoo. All right, let's flip those right off the bat. 216 over 125 to the power of, and then still 2 over 3. Don't flip those guys, right? The exponent never flips. Okay. Let's do the cube root first so we can make our numbers smaller. So the cube root of 216 is, we did that one already, yeah, 6. Cube root of 125 was 5. So we got rid of the cube root part. So now that's still all squared though. So now we're going to go 6 squared is 36. 5 squared is 25. Did you guys think for a second that we could do all that in our head? All right, so there are some word problems. I think I gave you guys one like this too. They're not so bad though. Like really, all we do here is they give you an equation, right? And we just need to plug the numbers in. They actually tell us. So here, paleontologists use measurements from fossilized dinosaur tracks and the formula this. Some smart person made this formula. To estimate the speed at which the dinosaur traveled in the formula, V is the speed in meters per second. S is the stride length. And F is the foot length in meters. So you use the measurements in the diagram to the right to estimate the speed of the dinosaur. Okay, so it told us that, what was the first one? S is the stride length, so that's this one, right? And they tell us that the stride length here is 1.10. Can you see that that is the same length as that, right? The stride length. So that we're just going to replace S with 1.10. F is going to be our print mark, so that's going to be 0.25. And then we really just throw those numbers into the equation. And then you just, this is like just punching it in with your calculator. So you can literally punch it in this way. You can go this times 1.10 to the power of 5 over 3 times 0.25 to the power of, and you can leave it this way. You can even go to the power of negative 7 over 6. Your calculator understands what that is, right? So that will actually just get you the right answer there.
Excuse me, why is it 0.92?
What do you think it would be? It rounded right here because that was a 1. And if it's a 5 or up, it rounds it up. So that's a 5, so it would round it up to 0.92. Okay, this one will be similar. It's a lot of just that you plug the number in. And, yeah. All right.